Okay, let's take a look at probability and odds. We're going to break 6, 7 into two parts. I'm going to just do probability for the first one and then odds for the second one. But on this first page, we're going to go over some important just vocabulary so we can understand what our probability definitions entail. So let's say you're conducting an experiment by rolling a six-sided die, and assuming it's a regular, it's not like weighted towards one side or anything. A regular normal die, 1, 2, 3, 4, 5, 6. The possible results of an experiment are known as the outcomes. These are all the possible things that you can get. So like I just said here, the possible results are 1, 2, 3, 4, 5, and 6. Those are the things that we can get. Now an event is something specific. An event is an outcome or a collection of outcomes. For example, that might be something like rolling an even number. Okay, that's an event. It's a collection of specific outcomes. Another event might be rolling a multiple of 3. Or rolling, we could go on forever, rolling a number greater than 2. There's a bunch of different events. Now each of these events are going to have different outcomes that you want to get, a different collection of outcomes, and those are known as favorable outcomes. So once you specify an event, the outcomes for that event are called favorable outcomes. So how about let's focus on rolling an even number. The favorable outcomes for rolling an even number would be 2, 4, and 6. Those are the things you want to roll. If you're playing somebody in a game and they say, all right, if you roll an even number, you win, you're hoping to get a 2, a 4, and a 6 because those are your favorable outcomes. They're the things you want. Now D is when we put it all together and we find the probability. Probability that an event occurs is the measure of the likelihood that it will occur. So what that really means is, let's say here, the probability of an event when all the outcomes are equally likely, we're going to take the number of favorable outcomes out of the number of possible outcomes. So let's go to our event we've been using, the probability of rolling an even number. The way we write it is we do our P for probability, and in parentheses we write whatever our event is. So our event is rolling an even number. We want to have that there. This doesn't mean, these parentheses don't mean multiply like they usually do in math. Here they mean like in English, you know, they're kind of citing what it is that you're referencing. So the probability of rolling an even number, we want to say how many favorable outcomes do we have? We have 1, 2, 3. 2, 4, and 6 are favorable outcomes. So we have 3 favorable. How many possible outcomes are there? Well, we're rolling a die, and we listed up above that our possible outcomes are 1, 2, 3, 4, 5, and 6. So we have 6 of them. So our probability is 3 out of 6, or 1/2. And that's really what you're trying to find. Probability that an event occurs. So the probability of rolling an even number is a measure of the likelihood that it will occur. So there's a half chance or 50% chance that you're going to roll an even number. And that makes sense based on our knowledge of rolling a number cube, or a die, as we said before. So let's take a look at example 1. Suppose you roll a number cube. What is the probability that you roll an even number? Well, we just did that one, so let's spice it up a little. How about a number greater than 4? Okay, so I'm going to change this in here. The probability of rolling a number greater than 4. All right, we want to see how many favorable outcomes do we have. Well, if we have, these are our possible outcomes. The things that we want to get would be 5 and 6. So we have 2 favorable outcomes. And how many total possible outcomes do we have? We have 6 possible, so 2 out of 6, and you always want to simplify it. So that means you have a 1/3 chance of getting a number greater than 4. All right, let's do, what is the probability that you roll a number greater than 1? We have to write in probability rolling a number greater than 1. And then we want to see how many favorable outcomes do we have. 1, 2, 3, 4, 5, 6. I'm sorry. We would have 2, 3, 4, 5, and 6 as favorable outcomes, which gives us 5 favorable outcomes out of 6 total possible outcomes.
Would Mrs. Zick please call the front office, Mrs. Zick?
What is the probability that you roll either a 4 or 5? We want to write probability, roll 4 or 5. How many favorable outcomes do we have? We have 2 favorable outcomes, 4 and 5, out of 6 possible outcomes. So again, we have a 1/3 chance. Okay? Alrighty. So let's take a look at the next page. And one more, there we go. The things that we've been talking about so far, rolling a die or something maybe like playing cards, this is known as theoretical probability. Theoretical probability is based on knowing all of the possible outcomes. Okay? So, in our case of rolling the die, we know that the possible outcomes were 1, 2, 3, 4, 5, and 6. If we were talking about cards, so a die is an example of theoretical probability. If we were talking about cards, that's another example of theoretical probability because you know all the possible outcomes. If you have a standard deck of cards, you have 52 possibilities. You know all the things that you can get. Okay? There's a separate thing known as experimental probability, and this is basically what it says. It's an experiment. You might not know exactly how many possibilities there are. It's based on trials, based on repeated trials. Okay, so what we mean by that is, let's say you go to a baseball game and you say, what are the chances of him hitting a home run? Well, there's not, like there were with rolling a die or a deck of cards, a set number of possibilities. Instead, it's based on repeated trials. So you would have to watch the pitcher, or you would have to watch the batter, you'd have to analyze what's going on, collect data, things like that. So repeated trials are the difference here. Experimental is based on it happening over and over and over, and then collecting your data. So experimental probability has a slightly different formula, but it's the same overall concept. The experimental probability of an event is the probability of whatever the event is, and then it's the number of successes over the number of trials. So this denominator is still the total that you're working with. So if you try something maybe 30 times, you try to throw a pitch and get it in the strike zone. You throw it 30 times, you have 17 successes, your probability is 17 out of 30. And that's all. So it's very similar. It's like what you want or what you get out of the total, as we saw with theoretical. Similar concept, just different phrasing. Okay, but we do want to make sure we understand the difference between theoretical and probability. Theoretical is based on a theory. It's what it should be, based on knowing all of the possible outcomes. Experimental is based on just repeating a whole bunch of different trials. Okay? Example 2, a miniature golf course offers a free game to golfers who make a hole-in-one in the last hole. Last week, 44 out of 256 golfers made a hole-in-one on the last hole. Find the experimental probability that a golfer makes a hole-in-one on the last hole. So probability of a hole-in-one, there are 44 successes out of 256 possible people who tried it. We can write that as a fraction and simplify. We get 11 out of 64. And then we can turn that into a decimal to figure out what our probability is. And it comes to be 0.172. We'll round it there. It keeps going, but it's about 0.172. Okay, and we're going to analyze that when we get down to here. But let's look at this one real fast. You interviewed 45 randomly chosen students for the newspaper. Of the students you interviewed, 15 play sports. Find the experimental probability the next randomly chosen student will play sport. So your probability, basically, that you get an athlete. Probability is 15 successes out of 45 people chosen, which is 1/3. All right, now all probabilities range from 0 to 1. You can never have a probability lower than 0 or higher than 1. They're usually going to be decimals that fall in that range, or they could also be written as fractions, but it will always be something in this range. 0 represents something that will never happen. It can't happen, 0 probability of it happening. 1 is definitely going to happen. Okay, so an example would be maybe if you're rolling a die, the chance of you getting a 1 through 6 would be definitely. That would be a probability of 1. If you're rolling a die and the chance of you getting a 7, you're just rolling one die, that's going to be 0. It's not possible at all because there's not even a 7 on the die. Okay? Alrighty. If you want to continue on, go to the next lesson and we'll finish it up from there.